This is a modern periodic table in which elements are divided into groups and periods. The element which form vertical column of the periodic table is called group, and the element which form horizontal row in the periodic table is called period. Today we are going to focus in the change of property of the elements as we go down in a particular group. I am going to show by this way. Let's say this is group 1A. And first element is hydrogen, second is lithium, third is sodium, fourth is potassium, and fifth is rubidium. There is cesium and francium also, but we are not taking a lot. In the same way, in 7A, look at first period is empty. And second period we have fluorine, third period we have chlorine and bromine and iodine. There is astatine also, but we are not taking a lot. I want to show the number of cells in each of them. Look at the hydrogen. It consists of only one cell. Lithium consists of 2 cells, and sodium consists of 3 cells, potassium 4, and rubidium 5. If an element falls in period 1, it consists of only one cell. If an element falls in period 2, then it consists of 2 cells. In the same way, period 3, 3 cells, period 4, 4 cells, and period 5, 5 cells. Have you noticed this? The atomic radius of this hydrogen is less, but comparatively lithium is more, and sodium is more than that, potassium more than sodium, and rubidium more than potassium, and cesium, francium, they have also more than rubidium. As we go down in a group, number of cells goes on increasing, and when number of cells increases, then atomic radius of the atom also increases. And this is one of the key factors which affects the property of the element. In case of hydrogen, atomic radius is less, so the attraction between the valence electron, group 1A has got only one valence electron in its outermost orbit, and the attraction between that electron and the proton is strong. But in case of lithium, electron is away from the proton, that's why comparatively attraction is weak. And in case of sodium, the attraction between the valence electron and the proton is weaker than lithium. As we go down, the attraction between the valence electron and the proton becomes weaker and weaker. As a result of this, what happens? When they take part in the chemical reaction, they have only one electron in the outermost cell. They tend to donate that electron. The tendency of donating electron increases. It means reactivity increases as we go down in group 1A. But look at this group 7A. I want to show the number of cells in each of the element. Fluorine has got 2, and chlorine has got 3 cells, and bromine 4, and iodine 5. But this group is not the group of metal. This is the group of non-metal, and this 7A has got 7 electrons in the outermost cell of their atom. They do not donate these electron to other in the chemical reaction. They have tendency to gain electron from other to form octet. As we go down in this group, atomic radius goes on increasing. The attraction between the valence electron and the proton of the nucleus goes on decreasing. Because of the less attraction, the tendency of donating electron increases. But they are non-metals, they have to gain electron in the chemical reaction. It means reactivity decreases as we go down. Now we can conclude that bromine is reactive than iodine, chlorine is reactive than bromine, and fluorine is reactive than chlorine. What can we conclude? As we go down in group 1A, reactivity of element increases because all of them are metal except hydrogen. Hydrogen behaves as metal. As we go down in group 7A, reactivity of element decreases because there are non-metals, and in case of non-metal they have to gain electron and atomic radius is increasing. That's why their reactivity decreases. Okay, this much for today.